So hello everybody, today we will be discussing a few problems on derivative as a rate measure. This has applications in calculus. So dy by dx represents the rate of change of y with respect to x, and this is the derivative as a rate measure. So there aren't too many formulas in this chapter, it is more application oriented. So let's start with problems. A stone is dropped into a quiet lake and waves move in circles at a speed of 3.5 centimeter per second. If the radius of the circular wave is 7.5 centimeters, how fast is the enclosed area increasing? Now area is pi r squared, so dA by dt becomes 2 pi r dr by dt, differentiating with respect to t. Now you are given that the waves move in circles at a speed of 3.5 centimeter per second. So dr by dt is 3.5. So dA by dt is 2 pi r into 3.5, and you are given that the radius is 7.5 centimeters. So put r as 7.5 and you get dA by dt is 52.5 pi centimeter squared per second. Coming to the next question. The two equal sides of an isosceles triangle with fixed base b are decreasing at the rate of 3 cm per second. How fast is the area decreasing when the two equal sides are equal to the base? So this is an isosceles triangle here. You have two equal sides, which is a, this is the base and this is the height. So using Pythagoras theorem, we can say that h squared equal to a squared minus b by 2 the whole squared, because we have a property that for an isosceles triangle, perpendicular from the vertex bisects the base. So this is a squared minus b squared by 4, or 4a squared minus b squared by 4. So h will be square root of 4a squared minus b squared by 2. Now area is half base into height, that is half base into square root of 4a squared minus b squared by 2, which becomes b by 4 into square root of 4a squared minus b squared. So calculate dA by dt. You are differentiating with respect to t, and go back to the question. Base b is fixed, so we are differentiating with respect to a will differentiate with respect to t. So it is b by 4, derivative of 4 root a squared minus b squared becomes 1 by 2 root 4a squared minus b squared d dt of this, which is 8a dA by dt. So this becomes ab by root 4a squared minus b squared dA by dt, and b is fixed, so that's why we are only differentiating a with respect to t. Now going back to the question, you are given that the two equal sides are equal to the base, that means a equal to b. So substitute a equal to b here, so you get b squared by root 3b squared, and you are given that the area is decreasing, the two equal sides are decreasing at the rate of 3 centimeter per second. So dA by dt will be minus 3, minus because it's decreasing. So this is minus 3b squared by root 3b, that is minus root 3b centimeter squared per second. Coming to the next question. A spherical ball of salt is dissolving in water in such a manner that the rate of decrease of the volume at any instant is proportional to the surface. Prove that the radius is decreasing at a constant rate. So it is decreasing, the rate of decrease of the volume is proportional to the surface. So dV by dt is proportional to S, or dV by dt is Ks. Now it's a spherical ball, so volume is 4 by 3 pi r cubed. So we have d dt of 4 by 3 pi r cubed equal to K. S is 4 pi r squared. So 4 pi r squared gets cancelled, 3 also gets cancelled, so you get dr by dt is k, which means that the radius is decreasing at a constant rate. Note that dr by dt is the rate of change of the radius. Question 4. A particle moves along the curve 6y equal to x cubed plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Now 6y is x cubed plus 2, so differentiate with respect to t. 6 dy by dt is 3x squared dx by dt. Now, so we have 3 cancels. 2 dy by dt is x squared dx by dt. Now the y coordinate is changing 8 times as fast as the x coordinate. So dy by dt is 8 times dx by dt. Substitute here. So 2 into 8 dx by dt is x squared dx by dt. So x squared equal to 16, or x equal to plus or minus 4. You have to find the point on the curve. So put x as 4 and minus 4 in 6y equal to x cubed plus 2. So you get it as either 11 or minus 31 by 3. So your points are 4, 11 and minus 4, minus 31 by 3. So that brings us to the end of this lecture. We have learned how to apply the derivative as a rate measure in problems. Thank you.